All right, welcome everybody to week 9, day 1. We're going to do a kind of an interesting thing today. I've been going over your quiz results, and there's some common mistakes that I've been seeing students make that we're going to address today. So, something I do, like one of the reasons why I give quizzes is so I can see like how you guys are doing. And if you're doing badly at something, well, then we get to fix it. So let's talk about range-based for loops. Actually, before we talk about range-based for loops, let's talk about how to make a vector. So there's kind of three different ways that I commonly make vectors. One is like this, vector of ints named vec1 semicolon. This is a size 0 vector of integers. Okay, it's empty. And so usually this is followed by a bunch of pushback statements, because pushback adds things to the end of a vector. So if it's an empty vector and you push back 10 into it, the vector now contains one element. Element vector.at0 is 10. And so typically size 0 vectors combo really well with pushback. Those are chocolate and peanut butter and banana, however you want to put it. They combo really nicely with each other. Second option is like this, vector of integers named vec2 of size 30. Yep. This is a size 30 vector, all of which are initialized to 0. Okay. This is pretty common also. Like if you know how many things you need, it's pretty common to create a vector of that size. So for example, if I wanted you to make a vector containing random numbers from 1 to 6 of size 30, you could do it a couple different ways. You could start at size 0 like this and call pushback 30 times, each time pushing a random number from 1 to 6 into it, which is what you're going to be doing during lab time today. Or you can create a vector size 30 and then do like a for each loop, right? So you can say for each integer call by reference, don't forget that, x is equal to rand, and I'm not going to give you the whole thing here, but like something, where it's going to be that element in the vector is set to a random number from 1 to 6. So in order for this to work, though, there has to be elements in the vector. So you can't combine this approach and this approach, because if you say for each element in vector 1, there are no elements. You can't do it. It doesn't work. So you have to like kind of think about which option you're going to take. And there's no right or wrong answer a lot of times. It just kind of depends on the needs of the assignment and things like that. So the other option is this will set it 0 to 2 billion or so. The third option is to do something like this, vector 3, and they're all set to be 5,000. 9,001. The power level is over 9,000. So this creates 30 elements, each of which is 9,001. So these are the three options for making a vector, and you gotta kind of play with and get used to all three methods. So that's kind of what I want you to do during lab time today. Just mess that. Now, one of the mistakes that I was about to talk about was this. So if you do call by value on a range-based for loop, what's happening is that it's going to copy each of those values out of vector 2. It's going to make a duplicate. It makes a clone. It clones each element of vector 2, which is going to be 0, but that doesn't matter. It makes a duplicate. It changes the duplicate to be a random number, and then it throws the duplicate away. So it does nothing. This is absolutely pointless for loop. We're a lot of times doing a lot of work to accomplish nothing. So some students always use call by reference, and that's kind of bad also, because don't use call by reference if you're not actually changing the thing. So for example, if you wanted to print all of the elements in a vector, the proper way of doing it is like this. Okay. And this prints every element in vector 2. Okay. So we start off by making 30 zeros, We set each element in the vector to be a random number from 0 to 2 billion. Again, during your lab time, you're going to set them equal to 1 to 6. And then we print it out. Okay, this for loop here should be called by value. This one should be called by reference. Why? Because we're changing it here, right? Here we're not. It would confuse us if printing a vector changes the vector, right? So it's called by value. That's just one of those rules of thumb you kind of just got to get used to. Other languages don't have the same options. Java enforces this rule, in fact, to a certain extent. Okay, so that's one of the things that I noticed. This, in particular, the difference between these two range-based for loops, a lot of students were getting wrong. And then the other thing that I noticed was non-standard for loops. And so the for loops that I teach are typically of this form, like for and I equals 0, I is less than 100, I plus plus, see out, I don't know, hello world. Okay. How many times is this for loop going to run? Power went out. Has anyone else lost power? Yeah. How many times is this for loop going to run? 100 times. Very easy, right? But like you might have seen from some of your homework assignments, sometimes you want to write a for loop that starts at not 0 and goes to not blah. And to do that, you have to kind of understand like a non-standard for loop, in which case, like let's say we're starting at 20 and going to 40, counting by 2s. Okay, so if you do this, this is going to print all the numbers from 20, all the even numbers, I should say. 20 to 40. Okay. So this is going to print 20. The next time through the loop, I is 22. Next time through the loop, I is 24. Now, could you do this with a standard for loop? You could. So how many numbers are there from 20 to 40? Does anyone know? Even numbers. How many even numbers are between 20 and 40 inclusive, including 20 and 40? And that's the problem, right? It's not 10, it's 11. There are 11. 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. There's 11 numbers. It's a fence post error, off by 1. Very common error. Everyone makes that mistake. So that's why it's nicer sometimes to do this. If you have a specific minimum and maximum and step size, that's the for loop probably I would recommend using. That said, if you wanted to use the standard for loop, you could do that. You just have to use algebra. Okay, there's 11 numbers. It's starting at 20, and the first time through the loop, I is 0, so it's going to be 20 plus 2 times I. So first time through the loop, I is 0. So this expression here evaluates to 20. Next time through the loop, I is 1, so that becomes 22. I is 2, that becomes 24, so on and so forth. Okay? So do you guys see how that works? So you can do it either way, and if this is the important thing, like if it's really important that you print out 11 even numbers, and I'm trying to highlight that fact that I'm printing 11 even numbers, I would write it this way on the top, option 1. But if I'm going to be like highlighting that I'm printing all even numbers between 20 and 40, then I'd probably do option 2 because it's a little bit more readable. I think you got the number, you got the starting number there, the ending number there, you got the step size here. Okay. So that's something that is probably good to practice with, and you will practice it because that's what we're doing during lab time today. So so the 3 learning points for today. Love caps lock. So non-standard for loops, good to practice with. You're going to get practice today. learning point number 2. I don't know if it's a learning point, but remember call by value versus call by reference in range 4. Oops. Learning point number 3 is going to be file IO with vectors. And so how do you read a vector from a file? How do you read and write a vector to a file? Okay. So as it turns out, it's pretty easy. So like let's say that we've got here code that is outputting all the elements of a vector to the screen. If you have an output file stream named, I don't know, somebody give me a variable name. Anyone? Variable name. It's the hardest thing in computer science for my output file. I just need a variable name. Foo, Craig. Okay. Craig it is. And the file that we're going to write out is called, I don't know, box.txt. I don't know. Like, kind of like, this code's going to be probably used for deal or no deal. So we're not going to be writing box data, but we're going to be reading it. But I'm going to show you how to write it first. Okay. So observe. Right now, do you guys all understand that this is saying for each element in the vector, print it to the screen? Are you guys with me on this? This is a very important line of code. You're going to do this all the time. That's how you print a vector to the screen. For each element in the vector, print it to the screen. Okay. So, in order to have the data go to a file instead of to the screen, we have to change one word. We change cout to what? What do I change cout to if I want it to go to a file, box.txt, instead of the screen? Keyreg. Good. That's it. That's all it takes. And now all of that data that was in the vector, all those random numbers, instead of going to the screen, are going to go into a file called box.txt. Box.txt makes the file, if it doesn't exist, and truncates it. Erases it, essentially. So if there was stuff there already, it's gone, it's erased, set to size 0, and then we put all the data from the vector into it. And likewise, you can read from a vector much like how you read from the keyboard. So you keep reading until you hit an end of file. Once an error occurs, you break out of the loop. So that's kind of what you're going to be doing in lab time today. So let's go ahead and run this. Okay. And so we can see here we've got, it's printing to the screen 20 to 40 and 20 to 40. And then inside of box.txt, you can see we've got 30 different random numbers ranging from 0 to 2 billion and change. Okay. Right, so that prints the values to the screen. This prints the values to the screen. This does not go to the screen. It goes into a file. Okay. So that is the lecture segment of today. It's 15 minutes long. Hopefully you're not bored by it. What I want you to do is you're going to use each of these 3 learning points in the lab time for today. Okay. So are you guys ready for this? You excited? Bencourt's excited. I know he is. Yeah. All right. Because if you can do the lab time for today, deal or no deal is not going to be a problem. All right. All right. So let's do this. Lab time. Okay. Step 1. Open a file and read all the data from it into a vector. Okay. Are you feeling it now, Mr. Krabs? Okay. So if an OF stream is used to output file, what is an input file stream called? An OF stream is for outputting stuff to a file. How do you read from a file? IF stream. Good. So if I wanted to read from a file, I'm going to need IF stram. There we go. There we go. So if we're going to read from a file, then typically the loop that you're going to write is something like this, right? While the file is still valid, integer x, we usually combine it with this lad over here, this mad lad. So we typically, if we're going to read from a file, we typically start with an empty vector, and then as long as we can keep reading from the file, we keep putting things into the vector. So this is the pattern. So ends double right arrow into x. So it's just like cn into x, right? But the numbers are coming from the file, not the keyboard. Do you guys see how similar that is? So it's almost identical to cn, except instead of cn, you write in ends or whatever you want the variable name to be. Okay. You always check for an error. Every time you do a read, you check for an error. And if an error occurs, just break. We're done. Because the most common error is we hit the end of file. Now, you might want to have something more robust than that that'll handle, like, if there's squirrels in there or something. But that's the basic idea. You just keep reading over and over again. And once you've successfully read in something, you call pushback. And so that will add each of the numbers in the text file into a vector. So vector is going to be size 30 now because there's 30 numbers in box.txt. That's what you guys got to do for deal or no deal. The only difference is the first line of the input file, and deal or no deal is the number of boxes. And so if you wanted to, you could make a vector of size whatever was on the first line there, if you want. I personally just read in the first number and then throw it away. I don't need it because I am a smart person using pushback. I don't need to know in advance how big the vector is going to be. So, yeah. Then if we want to print this to the screen, for integer x in vec1, cout x. And there we go. So you can see we've just loaded up all that stuff from box.txt. Try to edit box.txt and put in, I don't know, just sevens or something. Actually, I don't need to recompile that, do I? What happened there? Did I screw something up? Oh, there. Oh, right. We're creating random numbers, then overwriting it, right? Okay. So you can see right up top here, it read that number from the file, and then it generated a bunch of random numbers, and then wrote it back to the file. So, lap time. You're going to open a file, read all the data from it into a vector. You are then going to randomly add 1 to 6 to each of the numbers. You're then going to compute the average value of the vector and cout it to the screen. And then finally, you are going to write the vector back to the file. Okay. Now, if you're ever doing something like this, where you're like reading from a text file and writing to a text file at the same time, you need to put a close in between. So ends.close. Okay. And then that will close the file before you open the next one. This is only necessary if you're going to reopen the file later. Now, some people say it's always good practice to put a close in there. Personally, I don't worry about it because usually once I've outputted to a file, I return from the function and the thing closes itself automatically. But it's good practice for a situation like this because here we're opening a file and then here we're writing to the same file. So it's important to close it in between. All right. So that is that. Open a file, read all the data from it into a vector. randomly add 1 to 6 to each of the numbers. Hopefully you remember how to do rand. So we don't need these. Just put all this up on one screen. So see if you can remember how to do that. See if you remember how to seed the random number generator. Do you want us to create that file that you're reading from? You can. I would actually create it with all zeros or something, maybe 10 zeros. But then every time you run the program, I want you to read all the data into a vector. I want you to add a d6 to each one and then write it back out. So every time you run the program, the numbers are going to grow, but they're going to grow unevenly, right? And so it could be fun to sort of like see after you've run it 100 times, like which of the 10 values is the highest after 1,000 iterations or something. Yeah. So this is basically, a really important thing. Like having the skill of being able to just load from a file, work with it, and save it is how pretty much all modern, applications work. Like you open up a Word document in Word, you edit it, you save it, go home for the weekend, come back, you open it up, back up again. Okay. So this is a very fundamental skill we're going to be doing in lab time here. And I'm actually going to give you guys an hour to work on it. So I will be back at 4 o'clock or so. And then I will show you the answer then. So you guys are going to have like over an hour to work on this thing. If you have to go, it's fine. Once you finish it, post screenshots of your code onto the chat channel, and you have my permission to leave. Okay. So I'm going to give you guys an hour and 10 minutes to do this lab time. If you have any questions, just ask. I'm here. Mincarelli's here. Ben Court is here. Let's see if there's any other alumni. I guess not, just the 3 of us. Okay. So yeah, I would start by just creating a file with 10 zeros in it. Okay. And then see if you can remember how to do srand. Remember, CPP reference is your friend. If you don't remember which file has srand in it, you go on to cppreference.com. If you don't remember how to add up all the elements in a vector, you can always do a range-based for loop to do it, or you can do like cpp reference accumulate. That's a standard library function, and that's in numeric. So you have to hashtag include numeric to get that to work. And it's got some sample source code in here. Like here is a vector containing some numbers. Here's how you add them up. So if you want to do the average, you divide the sum by the size. So you take sum and divide by v.size, and then you would have the average value. And that's basically what you need to do for deal or no deal. So your lab time today, if you can get the lab time today done, then you're going to be good to go for deal or no deal. Okay. So if you're going to use accumulate, you need numeric included. All right. I'm going to pause the stream now. I'll come back after 4 o'clock and give you guys the answers. Peace out. Okay, so let's take a look at some of the code here. One thing I noticed is that all of you copied the fact, not all of you, but pretty much all of you, copied the fact that I didn't initialize x. That's bad. Do as I say, not as I do. So whenever you have a integer, anytime you have any sort of primitive variable, you always want to initialize it, even if the very next line is reading in from the keyboard. Just trust me on this. Just get into the habit of always initializing your variables. Too many people copied my bad practice on that one. All this looks fine. So you're starting with a vector of size 0, reading 1 int at a time from the file. Once you hit the end of file, it breaks. You're good. If it doesn't hit the end of file, then that integer that gets read in gets added to the end of the vector. And so if you have 10, 20, and 30 in the file the first time through the loop, it'll read in 10 into x from the file. 10 goes into the back of the vector. The next time through the loop, x is 20. 20 gets added. Next time through the loop, x is 30. 30 gets added. Next time through the loop, you try reading something, and it goes off the edge of the world. File becomes in the error state. It breaks, and then you can print out everything if you want. Here, though, you're immediately jumping to the next step. You're saying for every element in bra, and that's call by reference. That's good. You're going to take that element and add a d6 to it, 1 to 6 to it. closing the file. I probably would close the file here, because you're done with the file, right? So just conceptually, it doesn't make any difference, but like conceptually, like once you're done with the file, then call file.close if you need to close it. Then we've got a accumulate. Accumulate adds up all the elements. You could also do it this way, make a variable and say for every element in the vector, add that variable to temp, and that would add everything up into temp. Using accumulate is the standard library version of doing the same thing. Works just fine. And so that is the sum here. I would call it, yeah, I wouldn't declare y up here because you don't need it in the meantime. So that's just a style thing. Now, people who do a lot of C programming like to put all their variables at the top like this. I don't really like it because then you have to wonder like where y is going to come in, right? And so I would personally take this part out and put it down here and name y sum and say int sum equals accumulate, bra.begin, bra.end, 0. Don't forget the 0. And that's inside of the numeric include. And then the average is the sum divided by the size. That's cool. Be cautious if the vector is empty, then you got yourself a division by 0 here. So if you, I don't know, let's say the file doesn't exist. Then what will happen is it will skip over this whole loop and you will have an empty vector and your sum will be 0 and you'll do 0 divided by 0 and your code will crash. So be careful of that. So anytime I do a division, like the first thing that pops into my head is this going to be a division by 0? You know, is it possible for this division to, you know, be over 0? And in this case, it is. You can most definitely have an empty vector here. If the file is not open or if there's no data in the file, you will get, or if the first line of the code, the first line of goofy.txt is goofy, let's say, then that read will fail because you're trying to read from the file into an integer, and the first word in there is goofy, it'll break immediately, and you'll have an empty vector, you'll divide by 0, your code will crash, okay? So that's always something to check for, all right? And then we got here an outstream, writing to the same file for every element, and write to that file, which is exactly right. So I think you guys can see that writing to a file is not hard. It's just one word different from writing to the screen. Like it's just, what are you going to write to, the screen or to a file? They're exactly the same. Just one line of code extra, which is this line right here, where you tell it the file name to open, you give the variable name to write to, and you say it's an output stream or an input stream. Right? So yeah, looks good to me. Let's see some other ways of doing this. srand, yeah, always make sure srand's at the top of main. One student had the srand inside of the loop, which would keep resetting the random number generator to the same state, and you would keep getting the same random number every time. Like you would get 4, 4, 4, 4 every time. Unless like it happened to go right across the second boundary, in which case it would then be all 2s or something, right? So yeah, srand traditionally is just the first line of main. You just leave it at that. If you want to use a better random number generation system, you can look into hashtag include random in the standard library. Hashtag include random is better in all ways than srand and rand, except it's much harder to memorize. And that's why I teach the old C-style way, because first semester students can actually memorize it. I've yet to meet a first semester student who can memorize the correct way of doing it. Because it always involves you hitting up cppreference.com and copying and pasting over large blocks of code, which to me is just indicative of bad design. Like, really, what's more, you know, like there should just be a function, which I think might be coming actually, to just give me a random number from 1 to 6. Like, just handle it, you know. And I think that might be coming, so I'm excited for C++ 23. This prints out the vector twice. I'm not sure. Oh, no, that's Craig. Okay, there we go. So that's writing it to the file, and that's writing it to the screen. Okay, yeah, that's cool. All right. All the rest, yeah, this all looks good to me. Extra new line there for spacing, probably. Yeah, adding it together this way instead of accumulates is fine. Average, initializing to 0, average is 0 also. I probably would, again, declare these variables like down here, wherever they're used is typically where I like to declare the variables just as a style thing. Like I said, like your Zybooks and a lot of people who do a lot of C programming, like putting all the variables up at the top of them. I don't really like it. You don't need average until here, and so I'd say double average equals this. And then I think it looks better. You're free to disagree with me. It's not a big deal. Random function with the upper lower bound. Yeah, that would be like nice, and I think we're getting it. I've seen at least proposals for it. So let me see C++, C++ 23 random number. Let's see if there's a. I'll look into it. I've seen proposals for a better random number system. I'll tell you that much. Okay. Yeah. Overall, I think that looks pretty good to me. I'm looking at all your code, and I'm pretty happy. The only thing again is just initializing that. Do as I say, not as I do. Okay. Accumulate. There's also generate. Like if you want to generate a, it's like let's say you want to fill a vector with random data. I guess I can show you guys this real fast. So here we've got 30 elements that are all set to 9001. Let's say that I want to initialize, well, not initialize, but set all of the elements in vector 3 to random numbers of 1 to 6. There's a function called generate, and that goes from the beginning, let's say, to the end, let's say, of this vector. And then you can pass it the name of a function, like dice roll, or something like that. Does dice roll exist? No, I need to make it. But what this will do once I make the function is that it will roll the die, and then for each element in the vector, it will set that element to the result of the die roll. And so this will set vector 3 to a series of random dice rolls from 1 to 6. So let me show you this real fast. Int dice roll. Return rand modulus 6 plus 1. So this is a function that returns 1 to 6. And my sranding nope. Srand time null. And so what this is going to do, it's going to call the random number generator 30 times, one for each slot in the vector, and just make each value in the vector equal to that whatever. It'll roll the die and be like, all right, you're a 5. Roll the die, you're a 6. So if we 4 int x in vector 3, see out x, then what we'll get is a bunch, 30 different random numbers from 1 to 6. Okay, so that's kind of a fun way of filling a vector with random numbers. The reason why you'd want to do this, and I can show you an even more compact way of doing this. This and this do the same thing, actually. It's like a CSI 41 topic, but it's called lambda. Those two generates do the same thing. This is more of a, I'm not teaching lambda functions in 40, but just if you're curious, those two things are the same thing. So, so why would you do something like this? Why would you want to fill a vector with random data? Well, a lot of times we do that for testing, right? So if you write software that's going to like take a bunch of numbers and average them together or something, a lot of times, you don't want it to all be 9001s, right? You want random data, and so you'll make 30 random numbers, in this case 1 to 6, but 200s and 300s. Like you're writing accounting software and you want to test it. We'll just generate a whole bunch of fake data, and then see if our code breaks, see if we get a division by 0 or something like that, you know? So it's quite common for us to just generate random data and then try our code on it and see if our code explodes, which it might not if you're just manually entering a couple things, but when you have random data, it might. So this is a very, very useful technique, knowing how to just have a vector filled with random data. It's very useful. Basically, that's it for today. So the learning points again were: make sure you know how to do non-standard for loops. Remember the difference between call by value and call by reference and range-based fors, and keep practicing those file IO operations so you can read and write to a file instead of to the screen and keyboard. If you know that, you will be able to do deal or no deal. Deal or no deal is basically what you did today. Read a bunch of data in, average the result, and rinse and repeat. So that's due on Wednesday. So I'm expecting to see some questions start coming in on it. The input tester is working now. The input tester wasn't working earlier, but you should be able to test your code now and see if you get it working. It should be about 40 lines of code, something like that. All right, so that's it, everyone. I got one question coming in, it looks like, from Herbert. No, maybe not. Okay. So good luck on deal or no deal. This is basically what you need to know. And yeah, I'll be on Discord tonight, tomorrow night. Don't expect me to be awake late at night. I'm teaching 80 in classes these days, so I have to go to bed at a reasonable time these days. What do you mean by about 40 lines? Like about 40 lines of code total. Like what we have here is 45 lines. So you should be able to do deal or no deal in about this much. No 1 a.m. sessions. Yeah, maybe. I mean, it depends. I'm not that good at going to sleep early, but yeah, you should be able to do all deal no deal in a couple pages. If not, it's not a big deal. It's just kind of a ballpark notion. All right, that's it. Thanks, everyone. Thanks for all your hard work and lab time today, and I'll see you guys on Wednesday.